After understanding that light travels along a straight line, it is easy to understand how a solar eclipse is formed. The sun illuminates everything around it, including the moon. When the moon appears somewhere between the Earth and the sun while orbiting the Earth, a shadow of the moon will be projected on the Earth. The shadow of the moon covers a section of the Earth's surface at that moment, and the people in the shadow section cannot see the complete sun. This is a solar eclipse. Specifically, for example, the light from this point on the sun passes the edge of the moon and gets projected on Earth here, while another ray of light from the same point glides on the other edge of the moon and gets projected on another spot on the Earth. The shadow of the moon is created between these light rays. However, the sun is not just a one-point light source. It has a finite diameter. When observed from the Earth, the angular diameter of the sun is 0.5 degrees. It is small, but it is not zero. That means the diameter of the sun opens an angle of 0.5 degrees to a spot on the Earth. This angle shown in this sketch is made way much bigger than the reality to illustrate the point. The moon is much smaller than the sun, and also much closer to the Earth. The angular diameter of the moon is also about 0.5 degrees if observed from the Earth. That is a coincidence for now, and that can change millions of years later. Anyways, the sun is not a point source. Other points on the sun will also cause shadows of the moon, thereby resulting in the combined effect of many point light sources. The shadows generated by multiple point light sources will not completely overlap, but only partially overlap. The completely black area in the center is called the umbra. It is the area where all the shadows of the moon corresponding to each luminous point on the sun overlap. No light from the sun can reach this umbra area at this moment. People standing in this umbra area on the Earth and looking up will see that the sun is completely covered by the moon. This is called a total solar eclipse. The light ray represented by this yellow line can shoot straight from the lower half of the sun and get projected on Earth. In the annular area of this graying zone, some of the light from the sun can reach, while some of the sunlight rays are blocked by the moon. Those who stay in this ring area, this gray zone, are not able to see the sun completely. This gray area is called a penumbra. People in this area can see a partially blocked sun. This is a partial solar eclipse. Can you think about how an annular solar eclipse is formed? When some people on the Earth can see a ring of the sun like this. Let me give you a hint. What if the moon is a little further away from the Earth? As the moon's orbit around the Earth is not a standard circle, but rather an ellipse. If the moon is a little further away from the Earth, it may be far enough from the Earth, so that the completely black umbra area behind the moon, which is highlighted here, cannot appear on the Earth's surface anymore. After these two rays cross, such a new area will be created in the center of the eclipse region. This area is called a pseudo-umbra. The moon appears a little smaller than the sun at this distance and can only block the middle part of the sun. Light from the periphery of the sun can reach this area. Therefore, people living in this area will see the outer edge of the sun. That is, perceive the sun in a ring shape. This is an annular solar eclipse. At the same time, people in this surrounding gray penumbra area still see the partial solar eclipse. By looking at the size of these different zones, now you understand why the chance to see a total solar eclipse or an annular solar eclipse is much smaller than the chances to see a partial solar eclipse. The moon is slowly moving away from the Earth. Is that true? Eventually, after millions of years or billions of years, the total solar eclipse would stop happening forever. What do you think? Next, can you try to draw a picture to explain the formation of a lunar eclipse? Remember, the moon itself is not a light source. The moon is illuminated by the sun. When the moon moves to the shadow region of the Earth, there will be a lunar eclipse when it is not illuminated by the sun. Try to think about under what condition there is a partial lunar eclipse or a total lunar eclipse. Consider the size of the Earth and the moon. Is that possible to have an annular lunar eclipse when we see a ring of the moon from the Earth? Why or why not?